Science with Folly.
Atamarie, good morning and welcome to Science with Folly. Today we are learning about reaction rates and what is it that changes the rate of a chemical reaction. Before we get started, we need to recap two theories that we know. The first is particle theory. Particle theory states that all matter, that's atoms, molecules, ions, all matter is made up of tiny particles that are constantly in motion. And remember, temperature affects the movement of those particles. The greater the temperature, the faster those particles move. And this impacts the rate of reaction. The second theory is collision theory. And collision theory states that for a chemical reaction to occur, those particles that are in constant motion must collide with sufficient energy and at the correct orientation for a chemical reaction to occur. So there are four ways to change the rate of reaction. One is temperature. Two, changing the concentration. Three, changing the surface area. And four, introducing catalysts. Firstly, temperature. How does temperature impact the rate of reaction? Well, if we increase the temperature of a substance, the particles in that substance are going to be moving, they're going to be moving faster. And if they move faster, they're going to collide with greater energy, which means the reaction speed will increase. If you decrease the temperature, the opposite will happen. For example, if I stick some sodium into cold water, look what happens. Yeah, it's kind of exciting. If I put some sodium into hot water, look what happens now. Yeah, it's a little bit more exciting. But the key thing is the particles are moving faster. Concentration. How does that increase or decrease the rate of reaction? Well, when you increase the concentration of a solution or a substance, you're adding more particles. Think about acid. If we have a more concentrated acid, there are more acid particles or more hydrogen ions in the acidic solution to react. So there are more particles, means more collisions, faster reaction. The third way to change the rate of reaction is to increase or decrease the surface area of the substance that are reacting. For example, if you take a little piece of marble chip, drop it into some acid, only the outside part of that marble chip can react with the acid. If I take the same amount of marble, crush it all up into powder, put it into there, there is more surface area exposed. There are more particles exposed. Are there more particles? Well, no, because it's the same amount of substance, but there are more particles that are exposed for the reaction to take place, and therefore the reaction speeds up because there are more collisions. Lastly, catalysts. Catalysts are special chemicals that speed up the rate of reaction, but do not themselves get used up in the reaction. Some catalysts provide a specific site for the chemical reaction to occur, and others lower the amount of energy needed for the chemical reaction to occur. That's how they speed up a chemical reaction. One thing we have to remember with chemical reactions is the law of conservation of mass. Whether a reaction is slow or fast, if the amount of reactants is the same each time, the amount of products produced at the end of the reaction will be the same. If we look at the sodium and water reaction as we did earlier, the amount of hydrogen gas produced each time would be the same, even though the warm water produced that gas a lot faster than the cold water. So that was just a quick recap of what speeds up the rate of reaction. And remember, as long as we understand particle theory and collision theory, you'll be okay. Ka kite anō.
Science with Folly. Science with Folly. Science with Folly. Science.